Hello everyone. Today we will be continuing with the same chapter which is named as Motion and Time. Have you ever wondered that how did our ancestors used to measure time when there were no watches? Our ancestors noticed that many events in the nature repeat themselves after a definite interval of time. Example, they found that the sun rises every day in the morning. So the time between one sunrise and the next was called as day. So they took the time span between the one sunrise and the next sunrise as a reference and called it as a day. In the same way, a month was measured from one new moon to the next new moon, that which means that a month was equal to 8 phases of the moon. So as soon as the phases of the moon was completed, it was considered to be completion of 1 month. In the same way, a year was fixed as the time taken by the earth to complete one revolution of the sun. But what would we use to measure the intervals of time which are much shorter than a day? Yes, we use clocks or watches to measure the time that is shorter than a day. Working of clocks is based on periodic motion. One of the most well-known periodic motion is that of the simple pendulum. Here in the watches you can see there is a thing hanging down the watches which is moving. That is the simple pendulum. Now the working of simple pendulum. Simple pendulum basically consists of a small metallic ball or a piece of stone tied to a thread of 1 meter length and suspended freely from a non-moving stand. The metallic ball is called as bob. When the bob is taken at one side and released, it starts moving to and fro. During the motion, there are two positions where the bob stops and changes its direction. These positions are called extreme positions of the pendulum. Let's denote them by A and B. There is a moderate position between these two extreme positions. It is called as mean position. Let's denote it by O. जब बॉब रेस्ट पे होता है then it is said to be at its mean position, that is O position. The motion of bob or a simple pendulum repeats itself after a certain period of time. Such motion is said to be periodic motion. The pendulum completes its one oscillation when it moves from its main position to one of its extreme position and from there to the other extreme position and again back to the mean position. The time taken by the bob to complete one oscillation is called the time period of the pendulum. We measure the time period by measuring the time required to move from one extreme position back to the mean position. It is difficult to measure the time period in one go. Here is a method to measure the time period of a pendulum. Mark the mean position of the pendulum on the floor. Switch off the fan so there is no disturbance. Take a stopwatch. Bring the bob to one side and then release it. At the same time, start the stopwatch. Go on counting the oscillations. Stop the stopwatch as soon as the pendulum completes its 20th oscillation. Make a table and record the time to complete 20th oscillation. Take few more readings performing similar activity. For each reading, calculate the time period of the pendulum by dividing time by number of oscillation, that is 20. Is the time period same in all the cases? Yes, you will find that the time period is same in all the cases. A simple pendulum repeats its motion after fixed time period. We take that as its reference to measure the time. In fact, you can take any periodic motion as a reference to measure time. Watch works on the same principle. Units of time. There are different units of time: seconds, minutes, hours. Seconds is the basic unit of time, and minutes and hours are called as larger units of time. Also, we will see units of distance. Meter, kilometer, centimeter are different units to measure, used to measure distance. Now we already know that speed is equal to distance upon time. So its unit will also be measured in the same way. It would be meter upon seconds, it would be meter per minute, it could be kilometer per hour. So this was about the time relation between the time and the speed and distance. Thank you for watching the video.